Absolutely massive species of Jurassic lamprey unearthed, and this is the reconstruction of it. Can you imagine this thing looking at you or biting at you? Paleontologists have unearthed the fossil of two 160 million year old lamprey species, discovering the one small fish had already evolved into monster chompers, growing more than 10 times longer than the earliest lampreys. The earliest fossil evidence of lampreys dates back 360 million years, earning them the nickname living fossils due to their long history with little evolutionary change. Today they could grow up to a meter in length, that's about over 3 feet, though earliest lampreys during the Paleozoic were barely a few centimeters long. The largest of the newly discovered species, Yan Leo Mizon ocuser, was just over 64 centimeters, that's 25 inches, from tip to tail. The surprisingly ginormous ancient species were discovered in the terrestrial Yan Liao Biota in North China, and we can learn more about the evolutionary history of lampreys and where they originated thanks to these exceptionally well-preserved Lagerstate fossils. Bridging the recorded fossils and extant lampreys, these fossils offer an opportunity to reconstruct the evolutionary process and the ancestral state of modern lampreys feeding biology, writes a team of researchers led by Fei-Chiang Wu of the Chinese Academy of Sciences. Wu and fellow paleontologists Zhang of the Chinese Academy of Sciences and Philippe Janvier of the National Museum of Natural History in France conducted a comprehensive analysis of the two species, scanning with X-ray microcomputerized tomography to visualize the fossils in 3D. Along with hagfish, lampreys make up the living jawless vertebrate group, and these marine creatures resemble eels with their long and scaleless bodies, but actually eels are much newer species with updated bodily tech like jaws and bones. Lampreys are among the earliest vertebrates, and instead of using jaws like most regular fish, their quite terrifying circular sharp-toothed mouth sucks the blood of other fish. Lampreys have great weight in the study of vertebrate evolution, Wu, Janvier, and Zhang write in their published paper. They are characterized by their peculiar feeding behavior of eating blood or cutting off tissue from the host or prey to which they firmly attach via their toothed oral sucker. Lampreys' evolutionary history is still hard to figure out, though, because few fossils have been found. It's not clear when lampreys evolved complex teeth for feeding. Early lampreys in the Paleozoic had feeding structures that seemed too weak for predation, and they did not have the first larval stage of modern lampreys' life cycle, where their eggs hatch as blind worm-like critters that burrow in silt. The physiological implications of their size, along with other fossil evidence, suggest the newly discovered species had already evolved a 3-stage life cycle like today's lampreys. By the Jurassic period, the authors say lampreys had better ways to feed, bigger bodies, and were predators. These newfound Jurassic lampreys have the strongest biting structures of any known fossil lampreys, a strong indication of a carnivorous lifestyle. Yan Liao Mizon ocuser, to our knowledge, the largest fossil lamprey known so far, ranks among the largest in modern species, Wu and colleagues write. The adult size of living lampreys is directly linked to some of their most important biological traits. The bigger species can migrate farther and spread to wider areas, lay more eggs, and handle salt water better. Figuring out how the Jurassic lampreys lived and ate is easier when you know how big their bodies were. And what's more, skeletal remains, including teeth, jawbones, and even their skulls of unidentified bony fish, were preserved in the intestinal tracts of both fossil species. The bones, the skeletal relics, point to a flesh-eating habit for these fossil lampreys, the team writes, making them the oldest records of its group, with feeding mode clearly specified so far. The researchers think that rather than for predation, The smaller, more ancient lampreys' mouth parts might have been used to scrape algal mats off other aquatic animals. This would have helped them find a nutritional niche in a world crowded with jawless fish, like the similarly shaped conodonts. From their Devonian origins, lampreys' feeding structures and habits changed drastically, according to the authors, and these fossils bridge some evolutionary gaps, as well as changing what was thought about where living lampreys originated. Contrary to past efforts, they write, our study points to the southern hemisphere as a biogeographic source of modern lampreys. The study has been published in Nature Communications. This is by Rebecca Dyer on Science Alert. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.